Right, good morning. Let us continue our lesson. Today we are going to start with chapter 2, simulation. It's a small part. Only is one the first part I'm going to cover. The second and third part I'm not going to cover. That is not coming up for your assessment. All right. Simulation. The first part is simulation in new product development. Okay. First of all, the definition of simulation is a method of learning real system by some experimentation. Okay. By some experimentation, we are studying a real system by experimentation. So here we are dealing with we are going to experiment regarding the new product. Okay, before we, if your company want to develop a new product, it won't sell to the market immediately. Okay, one way of analyzing whether the product will be successful or not is by doing simulation in terms of getting a profit. Okay, a product, whenever you introduce a product and market, whether the product is successful or not, one of the criteria is we will look into the profit, how much we are going to get if we introduce a new product to the market. Now, one of the main objective of we are doing simulation is determine the probability that new product will be profitable, and these are the main thing. Okay, we are going to do now. We are going to analyze. We are going to analyze how much profit we will get based on probability. Okay, based on probability. But before we go straight away to the probability, let us see the basic first. Okay. Now look at this situation here. Seismic is a company develop a prototype for new high quality portable printer. So the new product is a printer now here. Now preliminary marketing and financial analysis provided the following selling price. Okay, they do have their marketing and financial analyst to do a pre-analysis before you I mean to do a analysis before they introduce this printer to the market, and they once they do the marketing thing, then they come out with this selling price, first year administrative cost and first year advertising cost. So these are the information they come out. Okay, this is a selling price. I think you need to copy this in your slide. Sorry for the delay in sharing the slide. I almost forgot that. In your slide you have to copy this, huh? These are fixed 259 per unit, 400,000 and 600,000. I call this as parameter. And then they also come out with labor costs. Okay, there are some cost inputs, labor cost, part cost, and first year demand. Okay, this much they need. So if I want to create an equation, I want to create an equation here, equation of profit. Okay, profit is actually revenue minus cost. So here the revenue is selling price multiply the quantity. 249x. What are the costs incurred here? I put here, this one is any cost here. Okay, there are two kind of costs. One is, I call this as fixed cost, and this is variable cost. So first I won't put the variable cost by 4590. I just put it as this is C1, C2. So where is vary according to the quantity. So I put C1x this is your revenue. Cost is C1x plus C2x part cost. And what was the fixed cost just now? You can see a fixed cost is this one, 400,000 plus 600,000, you get 1 million. So all these are costs you need to minus from the revenue, then that is your profit actually. So basically, if you want to simplify this equation, it becomes 249 minus C1, which is the labor cost, and C2 is the part cost, x here, minus 1 million. Give you some time to copy this. Then that's how I get this equation here. And writing a profit based on this inputs and parameter. Okay, once we develop this profit equation based on input parameter, we're going to find out profit based on some scenarios. Okay, based on some scenarios. It is not only one scenario. When I say scenario, it's based on some situation, based on some condition, environment. So it is not only one. We are going to go through many kind of scenarios based on the labor cost and part cost. Doing this kind of computation, profit computation based on multiple scenarios, we call that as what if analysis. What if analysis means we will ask, what if this C1 and C2 have different value, x different value, so what is the profit? What is the profit? So then maybe that is the reason they come out with this term, what if analysis. Okay. In this one also you need to copy. This one also you have to copy in your slide. right. Now we're going to compute the profit as I told you with based on some scenario. Okay, call it as best estimates. Let us estimate the profit now. Now whenever you have a single value, whenever they give you a single input, they say labor cost is 45 only, and make part cost is 90, and the demand is 15,000. Whenever they have single value, or whenever this is averages, average or mean, I hope you guys know how to compute the mean and average. Whenever you have a single value, then you just put inside the profit here, 45, 90. There's a typo here, you put a minus here, and this is your profit, 710000. This is your profit. And whenever your single value or average value, we call it as base case scenario. So the profit we are getting here is now base case scenario. Copy this. Now instead of having an average or mean, now let's say instead of having a single value here, okay, direct labor cost, part cost, first year demand cost, all these are inputs. Inputs. In a much more appropriate word is probabilistic inputs. We don't know, we just assume it may happen like this. Okay, now instead of having single value, let's say I give you a possible range, minimum and maximum value. Now labor cost can be in between 43 to 47, part cost can be in between 80 to 100, and the first year demand can be in between 1500 and 28500, something like that. Okay, this is now we are having a range now. So based on this, whenever they give you a range, then the scenario now becomes not anymore base. Of course we can find the base, but whenever they come out with a range, we can find two more the profit for two more significant scenarios. Okay, one known as worst case scenario. Worst case scenario means lowest minimum profit, when you will get a minimum profit. Okay, worst case scenario. You will get a minimum profit when the cost is highest, isn't it? So here 43 to 47, the highest cost is this one, part cost is this one, and for these are the costs. So for worst case scenario, for you to get minimum profit, you will put higher cost. There's a typo here. This is not 45. This is 47. And part cost is maximum. And then let me double check. Sometimes I do some mistakes. And for you to get minimum profit, your demand also will be less. Okay, so this is maximum, the cost is maximum, but the demand must be minimum so that your profit get less. So whenever they give you a range for the inputs, you have to adjust, you have to think which number you have to put inside the profit calculation so that you get a minimum profit, and that scenario known as worst case scenario. So in this worst case scenario, our cost will be higher, our demand will be less, and the profit is negative 847000, which means it's a loss. Negative means a loss. Copy this. Those who didn't see the range, his range is here. All right, this is worst case scenario. Then now you I guess you can guess that there's another scenario which is directly opposite of this, which is the best case scenario. So as I told you just now, for worst case the cost must be maximum, isn't it? So now for best case the cost is minimum. Best case scenario means maximum profit. So how you get maximum profit? This is minimum, and the demand must be high, maximum. In that case you will get a maximum profit. So in best case scenario, this is the profit. So in so far what we have done, let's say you are the manager of the task force for developing the new prototype. So once you go through the what if analysis with all this information, we come out that for base case scenario the profit is and for worst case scenario profit is and the best case scenario the profit is 2591. Now if you take the average, can you guess what is the average here? 710. So the average here is 818. Only with the three data here. Okay, these are the three data here. With the three data, we are getting this kind of average. So as a manager or the group head of the task force for the developing a new prototype, you bring all this information and going to present in front of your CEO of the company, and then the CEO says only with this data is not sufficient for us to come out with the best profit forecast or something like that. Okay, in that case he asks you to do more analysis. Okay, he not only want this base, worst and best case, only three. Is there any other possibilities for us to see more scenarios, more profit like this, more possible profit like this, and then take the average? Maybe that is much more accurate compared to taking just three data and taking the average and conclude that these are the profit we are going to get. And for that purpose, that is the reason we come out with the word simulation here. So simulation, basically we are going to do simulation now to increase the possibility of getting more data here. This data is only 3. For now, for simulation we can do as much as we can for come out with this kind of scenario. For practical practice purpose, for this class I just did 10. Okay, here 3, here 3, we are going to do 10. Okay, we're going to compute 10 profit like this, not based on some method here. Okay, so again, revisiting a simulation, just now we saw that the definition is taking a considering real lifetime by doing some experimentation based on some known inputs. Same thing here, simulation is, in other words, conduct what if scenarios by randomly generating a values of probabilistic input. So the what if scenario just now we're going to do again, but based on some probability. Okay, now let us move on. Let us see what now. First of all, as I told you just now, the probabilistic input in our current situation is labor cost. part cost. I call this as LC, part cost and demand. So since they are probabilistic input, okay, there are many chances for us to predict this cost. It is better for us to give a certain probability based on some probability distribution for each and every data there. So in this question we have fixed that direct labor cost will follow discrete probability. So the probability here is already computed based on discrete probability. Labor cost, just now we see in the range, isn't it, 43 to 47. Now we write it in each integer term. For 43, the labor cost, the chances for the labor cost will be 43 is 0.1, in other words 10%. The chances for labor cost will be 44 is 0.2, and 45 is 0.4, 46 is 0.2, and 47 is 0.2. So we give some probability now. Okay, so the higher chances for labor cost is 45. Same like this, we are going for part cost also. Part cost is uniform distribution. It has its formula. I'll give you later. For final year demand also, probability we go by normal probability. The formula I'll give you later. This normal probability I use. We can use Excel if you want to use this. Okay. Now we are going to. My idea is, as I told you, I'm going to compute 10 times, not only base, worst, and best. My idea is I'm going to compute, or in other words, I'm going to simulate 10 times. I'm going to take the 10 profit and I'm going to take the average. For me to compute 10 times, I need 10 labor costs. 10 part cost, 10 data of demand. So all this, we cannot simply pick the number. We have to go by some randomness must be there. Okay, so how we going to see for first time I'm going to compute the profit. Okay, I need to input this C1, C2 and X, isn't it? So how we going to pick the C1, C2 and X without any bias? Okay, any random numbers, any randomly we're going to use. So we are going to use random numbers for that. Okay, before we use random numbers, if I give you the value of cost, the probability, before we choose 10 labor costs, make sure you did random number intervals. Wait, this one I need to check whether which part you have to copy it. Okay, for you need to copy this one first. Copy the probability first. I'll give you some time. Copy the probability. Please mute your mic. I think somebody is not on the mic. Hui Teng. Pun Hui Teng, sorry. Hui Teng, mute your mic. Alright. Now once you copy the probability, let us construct the random numbers interval. So how I get this random number interval? You start with 0 0 if there's a one decimal place, and then you see the interval here, 0.1 minus 0.0, you get 0.1. This is a width actually, width of this interval. And then 0. This must be same, the number must be same. There's a equal here, there's no equal here, so you write the number here 0.1, and then what is the width? 0.2. you plus with this, you get 0.3. write the 3 here, you plus 0.4, what do you get? 0.7. That's how I do. That's how the random number of intervals are being done. In other words, the width of each interval is this one. Alright, so once you generate the random number intervals, now let us find the labor cost for the 10 trial or the 10 simulation. Now you can see here in the 10 simulation, here you have numbers, okay, random numbers is in between 0 and 1. Now for you to come out with the labor cost, for first trial, look at this number 0.9109. where it falls in this interval. So the first trial, for first trial, the labor cost is 47 here. Can understand? Okay, now I teach you for second one. 0.2841. 0.2. okay, the first one is the labor cost for the first one is 47. For the second one is 0.2841. 0.2841 is somewhere here, in between here. So the labor cost is 44. The third one is 0.6531. 0.6531 is somewhere here. The labor cost is 45. Hope you guys understand. Now continue. Copy this one. Okay, copy this one. Right here, direct labor cost. You try to do first. I have done for 3 for you. You try from here. So if you do that, okay, I suppose you guys have done is very short workout there, you might end up here. So this is your direct labor cost for the 10 simulation or 10 trial. So now you understand. Okay, previously for the base case we take the average, for the worst case we take the maximum cost, for the best case we take the minimum cost, but for this kind of simulation trial we use random number and some probability to get the direct labor cost, to generate, the proper word is generate, to generate the labor cost for 10 trial. So the same thing goes for the part cost and demand. We're going to take we're going to have some random number. Give you some time to copy this first. So whatever we did here is, if the cost is discrete probability, this is how we have to find the labor cost by using the random number. Next one is, this formula here is part cost. For part cost, now we say it's a uniform discrete probability. This is the formula, whereby A is the smallest value of the part, this is largest value of the part. If you see in the just now previously, the part cost, the range was 80 to 100. So if I want to write here, smallest value is 80, R is the random number in between 0 and 1, largest number is 180. So the equation can be reduced to this, 80 plus 20R. Now for you to find the 10 part cost, again we are going to use random number. We are going to insert here. Okay, the random numbers are here. Let me write the, okay, you copy this one first. So equation now is, part cost is, this is the equation I'm going to use. And if we want to compute the first trial part cost, that would be 80 plus 20R. The random number for the first trial is 0.26, and you will come out with a number here. Okay, the random number I will give you, don't worry. For the second part also, you will put a random number and you come out the answer here. This answer here is you will have here 85.36, and here the random number for the second one is 0. You can see that in your next slide. I just don't want to show you my next slide because it contains the answer I want you guys to do first. Okay. So this one is 80 plus 20, you will come out with 91.68. Okay, like this. In the next slide, you have a random number in the table, isn't it? I don't want to show that. First, there's a 3 column. So the first 2 I have done for you. You can start from 3 until 10. Get me the part cost here. Right, I suppose you guys have computed. Check the answer here. So these are the 10 uh, part costs. Check the answer. So we have 10 labor costs, we have 10 part costs. Now we need 10 demand. Okay, demand data for the 10 trial or 10 simulation. For that, okay, never mind. Check this one. All right. Hopefully you get all these answers here. For first year demand, the demand I'm using some Excel command here. Okay, these are the random numbers. Random numbers here is this one, and mean. I was using mean, this one, and standard deviation I put. So when I put 15,000, 4,500 into standard deviation, and the number of random number is this one, I get all this demand here. I think this one you don't need to copy, it's already given there. Of course in the exam I won't give you like this, or in the test I won't give you like this. So basically we do have all the inputs now for 10 trial. The direct labor cost, part cost, and demand. So for each trial we compute the profit. Just now we only have 3 profiters. We compute and we come out with the average now. Okay, all this average, this is also average. So this is, you have more information now here, and from this information we can say that highest profit is the 6th trial, loss is 9th trial, average profit, the probability of loss. Okay, how many times we lost? Only one time, isn't it, here? So 1 over, out of 10 trial 1 is lost, so this is the probability in case we want to present this thing. So these are the explanation. Now with all, if you do this kind of simulation, now if you want to present in front of the CEO, now it is much more comprehend and complete for you to present all this information, so that the CEO of the company is somehow confident regarding your analysis, instead of giving only 3 data just now. So this how the simulation help us to get much more accurate. I call this a much more accurate because we have done 10 times. The more frequency you do, the more accurate you will get to the real life situation. That's how the theory goes. Okay. All right, this is something to do with simulation with new product, and this is also simulation with new product, also known as risk analysis. Whenever you heard any where risk analysis, this is predicting some outcome in the decision of uncertainty. Uncertainty means we don't know the real value, we go by probability. All right, now exercise in class 1, try to read this. All right, so these are the probability of creating a new account in each seminar. So for this you develop an interval. So this is the interval of random number. Set up intervals of random numbers that can be used to simulate the number of new account open at the seminar. So we have done this A. Using the first random number in the column 9 in the table. So this one I will give you. Now I will give you. Simulate number of a new account number. Alright. So that 10 random numbers I'm going to write here. Random numbers, huh? Now number of new account, number of account open, now 0.7169. 0.7169 is where? Here. So you open 4 account here. For seminar 2, in the seminar 2, 0.21. 0.21. Did I do any mistake here? No, okay. 0.21 is here. 3. Okay, now you proceed. See how many account is open for each and every seminar here. There are 10 seminars basically. So if you compute all, you should get 3 here, 5 here, 2 here, 6 here, 4, 4, 4, and 2. So all together, this you get 37 new account. Would you recommend Gustin continue running the? Let us see how much the commission he get. The commission is the profit, something like profit. For each new account, open, he get commission 5,000. So they are based on simulation. There are 37 new account times by 5,000. You are getting 17550. This is the commission you get. But what is the cost for each seminar? There are 10 seminars, right? 10 trial, 10 seminar. For each seminar it costs 3500. So 10 seminar, $35,000. So basically the profit is from the commission minus 35000, you are getting 150,000. Still you have profit here. So the answer is you will recommend Gustin continue running the seminar. You write your own words. Alright, exercise in class 2. Try to read first. There's a new product. As I told you, there's a purchase cost, labor cost, and transport cost. These are the costs involved. Assume that these are only costs. Assume that these are the only costs and that the selling price for the product is 45 per unit. Provide the base case, worst case, and best case scenario. First of all, the profit formula is this. Selling price, which is 40 per unit, per unit, 1 unit. So you don't need to multiply with X here. They only ask for per unit. Minus the part cost, minus the labor cost, minus the what are the costs? Transportation costs. They want base case scenario. For base case scenario, for base case you take the average of everything, all the thing. So if you take the average here, you plus all, okay, this one is 33 minus divide by 3, you get 11. This one, if you plus all, what you get? And you get 91 divided by 4, you get 22. 8 over 2, you get 4 here. So these are the averages. So for base cost, the profit would be 45 minus 11 minus 22.75 minus 4, you will get 7.25. For worst case, I told you the cost must be higher. So the worst case, take the highest maximum cost minus the maximum cost, minus 12, 25 minus 5, you will have 3 here. And for the best, you will take the minimum cost, 45 minus 10 minus 20 minus 3, you will have 12 here. This is the answer for A. Now for B, set up interval of random numbers that can be used to randomly generate 3 cost components. Let us set up this part cost, the probability, I'm going to do all together. This is part cost, labor cost, transportation cost, this is B, set up a random numbers. Sorry, random intervals of random numbers. So for C, we're going to use these random intervals. Okay, just imagine this is for this random number. We using this random number calculate the profit. So this one is PC. This one is LC. This one is TC. Same goes here. This random number is for TC, LC, and so the profit for these three numbers in C is minus 0.37 somewhere here, so you choose this one. For part cost, labor cost 0.58 somewhere here, you choose this one. And transportation cost is somewhere here, you choose this one. And the profit is 5 for D. Part cost 0.18 is somewhere here, you choose this one. Labor cost 0.74 somewhere here, you choose this one. And 0.61 somewhere here. All right. So that's all regarding simulation on the first part, as I told you. And the second part, inventory simulation, and the third part, waiting line simulation, I will not go through, because normally these two simulation I will explain to you, because last time I used to give assignment based on this. Now your assignment is different now, so I'm going to skip this. In that case, that's all regarding chapter 2. Next class will be chapter 3. Okay, chapter 3 or some other chapters I will update you next week. Alright, so that's all for today. I'll see you all next week then. Take care. Bye. Another thing, so we finished simulation here. I have sent you the extra exercises, right? The extra exercise, the last part is simulation. Now you can try do that exercise, prepare yourself for the test. Okay. Alright, that's all for today. I'll see you guys next week then. Take care. Bye.
Thank you, doctor.
Thank you, Doctor. Thank you.